Hey guys, how's it going today? I'm Mrs. Bukaki. For those of you who do not have me for Algebra 2, I'm going to take care of the lesson today, Section 3.2, Solving Systems Using Substitution. Now typically we have solved systems by graphing. So say for instance you had two graphs, two lines here, and their solution set would be where they meet, right? Okay, so this is another way to represent that algebraically by substitution, because sometimes on a coordinate plane your solution might not be so easily seen. It might be 4 2/3 and some numbers that aren't nice even numbers. So let's go ahead and I'll do some examples involving substitution. Alright, so here's an example. Here's my system, my two equations. Again, if I were to solve for y and graph these, where the two lines meet would be my solution. But let's try using substitution. So the goal behind substitution method is to isolate one variable and then plug in what you found to your other equation and solve. So let's work on that now. A couple of tips. You ask yourself, well, which variable do I choose? It really doesn't matter, but I always try to do something that makes it a little easier on yourself. So, like for instance, if you were to solve for x on the first equation, you would have to divide everything by 4, and here you would get a fraction 3/4, which isn't bad, but just keep in mind you might be working with fractions if you choose a certain equation to work with. So I see my y here is already kind of isolated. It just has a negative out in front. So let's solve for this and then plug in what we find into this equation. Alright, so I have 2x minus y equals 7. Again, my goal is to solve for y, so get everything else on the other side. So I'm going to subtract 2x from both sides. Negative y equals 7 minus 2x. And again, I have to get rid of this negative, so I am going to divide by a -1 all terms. And I'm going to get y is equal to -7 plus 2x. Okay? So now that I know what y is, I can plug that back into my first equation, the equation that we haven't worked with yet. So I'll make kind of a nice squiggly line here and do that. 4x plus wherever I see a y is where I'm plugging -7 plus 2x. Plus 3 times -7 plus 2x. And that equals 4. Kind of ran out of room there. So let's distribute and combine some like terms. I have 4x minus 21 plus 6x equals 4. What are some like terms? So I have a 4x and a 6x. 10x. I can also add 21 to both sides. So I have 10x is equal to 25. Last step. Divide by 10. X is equal to 25 tenths, or we know that can be reduced by dividing top and bottom by 5. So we get x is 5/2. That's only half the battle, though. We still need to know what y is. So in order to do that, we can take what we found for x and plug it back into either original equation. Okay? It has to be into the original equation, so keep that in mind. Let's do that. Okay, so let's take our x and plug it in. I kind of created a new slide here. Here's my same system, my two original equations, and on the previous slide we found what x is. So let's plug that in. Again, make it easy on yourself. If you see things that are going to cancel right away, do it. So for instance, I know if I plug in a 5/2 here for x, my 2's are going to cancel, and I'm just left with 5. So I am going to pick this equation to work with. So I have 2x minus y equals 7. I'm just kind of pulling it apart here. And now I'm going to add my 5/2 in wherever I see an x. Okay, so 2 times 5/2 minus y equals 7. My 2's are going to cancel here when I distribute, which just leaves me with a 5 minus y equals 7. Subtract 5 from both sides. I get negative y equals 2. I can't have that negative in my variable. It needs to be completely isolated, so I can divide by a negative 1 on both sides to get y is equal to negative 2. Alright, so I have my x, I have my y, and you would want to write it in proper term format as a coordinate. So 5/2 negative 2 would be your solution. What can I do to check that? I can plug these values in to either one of my equation, and if it equals 4 or if it equals 7 down here, then it'll work. So let's just quickly do the, we'll use the bottom one, 2x minus y equals 7. So let's plug in our x and y to see if our solution is correct. So I'll kind of, see, 2 times 5/2 minus a negative 2 equals 7. My 2's cancel. 5 minus a negative 2, which is plus 2. Does that equal 7? Yes. And we are finished. So let's do one more example with substitution. I have my system here, and let's start off by solving for a variable. You can choose which equation, which variable you want to solve for. Again, make it easy on yourself. I notice offhand that if I choose to start with x, it looks like I'm going to be dividing by 3 for everything. That'll give us some nice even numbers. So let's do that. Let's pick the top equation and solve for x. So negative 6 equals 3x minus 6y. And again, I'm solving for x. I want to get everything on the other side, so I'm going to add 6y. So I have 6y minus 6 equals 3x. And now to get x by itself, divide by 3 to get 2y minus 2 equals x. Okay, so we have what x equals. Now we need to plug that into the equation that we haven't worked with yet, wherever we see an x. I'm kind of going to draw a line here. Let's do that. Wherever we see an x, I'm plugging this into it. Okay, so 4 times what x is, 2y minus 2, equals 4 plus 5y. Let's distribute and combine like terms and solve for y. So when I do that, I get 8y minus 8 equals 4 plus 5y. Add 8 to both sides. 8y is equal to 12 plus 5y. And subtract 5y to both sides. You get 3y is equal to 12, or y is equal to 4. Alright, so we found our y, but we're not done yet. We need to find what x is as well. So again, you can plug this value in to either one of the original equations, either one. So here are my, here's my system again. I just rewrote it on a new slide. And what was 4? Y was 4. Y equals 4. So let's plug that in to, again, either one. I'll just choose the second equation. Wherever I see a y, I'm going to plug 4 in. So I have 4x equals 4 plus 5y, or 5 times 4. 4x equals 4 plus 5 times 4, which is 20. 4x equals 24, and divide by 4, x is equal to 6. So my solution for this problem is 6, 4. And we're done. If you wanted to check your answer, if you were unsure, again, just plug it into either one of the original equations. Thanks for listening, guys.